Hello fellow problem solvers. So they're going to be doing a problem from the 1992 IMO problem number 2. I suggest you try this nice functional equation problem out for a minimum of 45 minutes. Ideally an hour and 15 minutes to hour and 45 minutes, not more than 3.5 hours. If you'd like to go along with us, give this a go for the next 10 minutes first. For 10 minutes, what are the first things you notice here? And for me, the first thing I notice is that this y, right here, is free floating, which means I can sort of fix x to be a constant, and then I'll get all the numbers here, hereby proving that the function is in fact a surjection. But also I can get an injection. I have a y here. If f of a is f of b, f of a plus x squared is f of b plus x squared, and then f of that is equal to this, and from there I get a is equal to b, right? So I can prove injectivity and surjectivity. If this is too difficult for you, then maybe this function is a bit too hard at the moment. Try to solve some of my other easier, more functional equations to get to this level. And with this in mind, what is the next step we're going to do? I invite you here to pause for 2 minutes and ask yourself, what do you want to focus on? For me, personally, I see f of x is a solution. I can go ahead and try to prove that we have only fixed points, look at the fixed points of this function, but it's hard to find points f of alpha is equal to alpha. Like I need to assume such a thing exists. And it doesn't seem like I have a quick way of getting to that thing. So that's not it for me. Now, let me look at a zero then. Let me find something that's equal to a zero. So I'll have that, first for every x, there will exist a y such that f of y is minus x squared. And then, but this doesn't give me f of 0, right? Like if I don't have f of 0, that doesn't mean much to me. So let me try to find what f of 0 is. Now I see like plugging in, let f of 0 be equal to c. And let f of some alpha be equal to 0. Go about it two ways. One is prove that alpha is 0, the other one is proving that c is 0. One way should work. So let's see what happens when I plug in like the general let p of xy be equal, give us this. What happens when I plug in, say 0 and y? I'll get f of, what do I have? F of y is equal to y plus c squared. Okay, and then f of p of x and 0 gives me f of x squared plus c is equal to f of x squared. Okay, nothing right away is popping up. Though maybe, though right now, for me something is popping up. If I plug in here x is equal to alpha, I'll get f of alpha squared plus c is equal to 0. But this is f of alpha already, so I have alpha squared plus c is equal to alpha. Which, maybe there's a way to use this. And I'm also looking at this, if I plug in y that's equal to alpha, I'll get f of alpha, so I'll get f of 0. If I plug here, y is equal to alpha, I'll get f of alpha is f of 0, and that's c. I'll get c is equal to alpha plus c squared. Now, is there anything with these two things that I can infer? Like there's a relationship between c and alpha here. And the answer is, well, this thing, if I just plug in c now, is equal to, then I have alpha is equal to alpha squared plus alpha plus c squared. The alphas cancel out, and I have alpha squared plus c squared is 0, which implies that both alpha and c is equal to alpha, is equal to 0. And so, this is an interesting thing. Like we've used both of them in a sense, right? We've used the value f of 0 and f of alpha is equal to 0 to get to the both of them need to be 0. And now we have f of 0. And here I invite you to pause for another 15 minutes and see what would you do next. Here's my next step. So I have f of 0. Let me see what do I have from f of 0 is 0. I'll get that f of x squared is equal to f of x squared. Does this tell me anything important? You know, sometimes we mindlessly just plug stuff in and just go like, okay, now this, let me try to get something that's together, blah, blah, blah. Think about it. Let's just give us anything interesting. Anything. The answer is it does. It gives us a bunch of things. The first thing it gives us is, if I, instead of x, I plug in minus x, I'll get this as f of minus x squared, right? So I get, because of injectivity, f of minus x and f of x can't be the same. So I get f of x is equal to negative f of minus x. That's the first thing I get. What do I also have? I get that f of positives is always greater than 0. Right? And then f of negatives is always less than 0. So x greater than 0 implies f of x greater than 0. And in fact, f of x greater than 0, if we think about it, f of x less than 0 implies f of x is, what's it called, less than 0. So we have an if and only if here, right? X and f of x are of the same side, right? Maybe that's useful here, maybe it's not useful, but let's have that in mind here. It might be useful at some point. We also have plugging in p of, what's it called, 0 and y, gives us f of y is equal to y. And now what do we do here? Well, for me, when I think about this equation, and I think about this fact, I immediately want to go, wait a second, if I plug in now p of x and f of y, I'll get x squared plus f of y, which is f of x squared plus y, is equal to f of y plus f of x squared, but this is the same as f of x squared, which is a Cauchy type of function. If I have a z that's greater than 0, I'll get f of z plus y is equal to f of y plus f of z. So this is for z that's greater than 0, and y can be anything. And now with this and everything we've done so far, I invite you to take another 10 minutes to try to push this problem further. And now what do you see? Well, wait a second. I know that this thing is greater than f of y, right? If z is greater than 0. And it doesn't make sense for us to look at like any to y is equal to 0. That's, we already have everything from there over here. So we have this. Now, it doesn't make sense. It doesn't make sense to look at x is equal to f of 0. My bad. X is equal to f of 0 or 0. So we have this function is in fact strictly increasing, right? We have a strictly increasing function, and we have f of that function is the thing that we're fing. So this is where I want to show you an end that I saw in a problem that I just think is very, very cool. And it shows like there's many ways to go about solving a Cauchy function. Like maybe you show that this is, that on some interval it's bounded. I don't know these things, right? I can't prove them. I don't like memorizing stuff. I like solving them from the ground up. And now, how are we going to go about this function? Like, we have a lot more than it just being a Cauchy. I plugged in a very specific thing to get that it's a Cauchy function. So here's what we do. We can say, what if, so I have a greater than b implies f of a greater than f of b. Because I can just set, b is equal, y is equal to b, z is equal to a minus b. And I'll get that from here. Now I invite you to pause for 5 minutes and try to solve the problem. And the thing is, from f of a is f of b, that gives us f of a is also greater than f of b. By the way, this is a, this is b. How am I going to use this? Okay. What if, there's two things that can happen. What if f of x is greater than x? Well, then we have f of x is greater than f of x, which we know is greater than x. But f of x is equal to x. A contradiction. What if it's the other way around? What if we have f of x is less than x? Well, then we have f of x is less than f of x, which is less than x by this, but then this is equal to x. A contradiction again. And this finishes up the problem. This means there can't be an x which is less than that. There can't be an x whose f is bigger than it or smaller than it. So that forces f of x to be equal to x for every single real number x. And when we check it out, we get x squared plus y is y plus x squared. And this is a function that works. This might be a short video, but this problem is difficult. I've just given you the steps. There's a lot of thinking going behind this. I, in fact, tried to solve this problem for much, much longer than the length of this video. And I had trouble, right? I had trouble. I needed to even look at the solution to figure out, oh, that's the hint I need. But this finishes it up, right? For me, I had trouble. Let me tell you what I had trouble with. I had trouble figuring out from here that the function is strictly increasing. I had this Cauchy-like thing. And I was trying to get like, oh my God, how can I get that the function is now strictly increasing? And I got, like with a Cauchy, I had the rationals, right? I had them immediately, all the rationals. Like f of q is equal to q times f of 1 for every q. And then I need to figure out, oh, okay, from here I get f of 1 needs to be equal to 1, right? So I get f of q is q. And then can I do some sort of bounding contradiction? Oh my God, I couldn't do it. And then I saw like, wait a second, you have that by just, instead of rewriting it, which is also a danger sometimes when you rewrite stuff, make sure you've gotten everything you can from the thing before you rewrite it, right? Because here it matters just that the positives go to positives, negatives to negatives. Then you can show that this function is strictly increasing pretty trivially, like pretty quickly, if you know that. But it's a difficult thing to see. But this finishes up our problem, and as always, thanks for problem solving.